So, hello everybody and welcome to this webinar with the topic Safe Energy Control Technology, the new product family for surge protective devices. My name is Thomas Bings. I am working in the product marketing of the business unit for surge protective devices from Phoenix Contact. So first I want to start to present Phoenix Contact. I am welcoming you from Blomberg, which is a small city in North Rhine-Westphalia, in the east of North Rhine-Westphalia. You see here on this picture the whole headquarters of Phoenix Contact, and up to 5,000 people are working here, so it's quite a big company. And over the last years we had quite good success, and we have a rising number of employees. Nowadays we have 14 million employees, and we have a turnover of 1.7 billion euros. So quite successful story. And as we are a quite big company, we also have a global sales network. So if we look around the world, we have a lot and a lot of countries where we have a representation, a sales representation. So this is the whole network. And we also have a quite big range in our product portfolio, and we are doing electrical contact and automation technology. And the highlights in this year were, for example, marshalling systems with push-in tech connection. We have a new high current spring cage terminal blocks. We have robust power supplies and multi-channel circuit breaker, very compact circuit breakers. We have a new safety technology, safety relays on 6 millimeters, and the topic today is the new surge protective devices family, safe energy control technology. So the agenda for today is, at first I want to present some basics of surge protection. And then I go to the new family, the presentation of a new family, the main features of the new family, and some application examples for the devices. So let's start. What is surge protection? So what do we protect for? What is our protection for? So I have a short video. We are protecting against transient voltages, and what a transient is shown in this video. I will start this here. We have a typical, the typical voltage in a grid, an AC voltage, and the transient is only visible if we have a really short period of the grid. This is one sinus wave, and there you can see the transient. It's only some microseconds from the duration. So in the normal grid you can't see the transients, but in a short period of time you can see the transients, and these transients can destroy the electrical installation and some electrical devices, and this is why we need surge protective devices against these transients. And so how can these surges, these transients, stress the electrical equipment? Where do they come from, the transients? So there are different possibilities of why a surge can appear. A very famous reason is the direct lightning strike. So here you see a typical building, and it is provided with the power supply, its connection to the local power supply, and it has an outer lightning protection system on the roof. And if you have a direct lightning strike, the lightning current flows through the connection, and all connections in parallel are in danger for getting inductive incoupling of the current. And we also have a galvanic incoupling into the electrical system, because our outer lightning protection system is connected, of course, to the earthing system, but also to the inner electrical installation. And so the lightning current that hits the rooftop, it has a direct connection to the electrical installation inside the building and can destroy this building. And here is again the typical building, and how the lightning comes into the building I will show further on. So we have the outer protection system on the roof, and now we have a direct lightning strike, and the lightning current is looking for its way to the ground potential. And typically, or no, it has one of the ways to the ground potential is the local grounding system, and another possibility for the lightning current to find the ground potential is the ground potential at the transformer. So it has a second way to the ground potential through an electrical installation inside the building. And so if this way is taken by the current, or it is taken by the current, it destroys the electrical installation inside the building. And typically we say that 50% of the lightning current goes to ground and 50% goes through the interior electrical installation. So a second possibility for surges can be a distant lightning strike. Also, a distant lightning strike is a danger for the inner electrical installation. So why is this the case? Here again, the building, and we have nearby a tree, for example, and if the tree is hit by a lightning, it arises the potential, the earth potential here in the tree rises in several kilovolts, and the area around the tree also rises this earth potential. So there is a big potential difference between this earthing point and the earthing point at the transformer. And so the current searches its way through the electrical installation to the transformer because of the potential difference between these 2 points. So this is also a dangerous situation for the inner electrical installation. And another, surges are not only caused by lightning strikes, but also by switching operations. For example, switching operations in the grid. If you have a switch of high loads in the grid, for example, by construction works. So this is not a way that should exist, but it may appear that construction work destroy the cables inside the earth, and so you have a switching operation, and you also have surges for the electrical installation that can destroy the devices. But here is an example how surges can appear from little devices. For example, if we have a 24-volt DC contactor, this 24-volt DC contactor also causes surges in the grid. And it's not only if we switch high loads, but also these small devices causes surges, and I will explain it with this video here, where we have a measurement on this contactor, on this 24-volt DC contactor, and we will see which voltage comes out at the installation. So, as we have seen, surges also appears from smaller devices, as they are installed 1,000 times in typical installations. So there are also inside the building, there are reasons for surges for the electrical installation. And this is dangerous for the devices, and this is what the surge protective devices protect against. So how do these surge protective devices work? So here we have a device that is connected to two potentials, the A potential and the B potential. And if nothing special happens, the surge protective devices works as an open switch, so it has no influence on the electrical behavior of the device. But what happens if the potential difference between A and B rises to to a value that is not normal for this installation? So if we have a transient, a short time transient between the phases or from Earth to phase, the surge protective device does nothing else than a potential equalization. So we say we close the switch and the current cannot flow through the device, and this is only for really short period of time. So here in this case, the end device is safe because no voltage is over these two phases, and we have a short circuit inside the surge protective device. But this short circuit is only during a very small time, only for microseconds, then it is open again and the devices work as if nothing has happened. So again, this principle for the building, what does this mean? Again, we have a direct lightning strike in the outer lightning protection system, and the current is going through to Earth and is going also in the inside of the house, in the electrical installation. And now we have to avoid that this current is going through the electrical installation, through the devices to the transformer. So we install another way for the current to go to the transformer. We install the surge protective device, short SPD, and now the current can flow through this through the surge protective device and not through the electrical installation, and the electrical installation is safe in this case. So this is how surge protective devices work. And now I will come to the presentation of the new Safe Energy Control family, the new product family for surge protective devices. So I will start with a short video which will introduce the new family, and then further on then I will explain the points that are mentioned in the video. So first, the video.
The requirement surge protection devices must fulfill is that the customer can rely on them 100%. The system must continue running at all times. The best surge protection is one that the customer does not even notice during the service life of the system. With this new technology which we developed for SEC, we have truly reinvented surge protection. The main benefit for customers of the SEC family is quite clearly spark gaps without line follow current, so they have absolutely no negative effect on the system. This behavior protects the system, and paired with backup fuse-free usability for nearly any application, the highest performance and long service life. This is exactly what gives the SEC portfolio the finishing touch. These features will clearly inspire our customers.
Die SEC-Familie bietet neben den...
The SEC family offers, in addition to arresters, which can be used without a backup fuse, also products with an integrated backup fuse. This gives customers a very high level of flexibility for the installation and layout of surge protection in their systems. They ultimately need to connect only one product. There's no need for additional fuses, fuse holders, or the wiring in between, not to mention the space saved in the control cabinet.
Platzvorteile in seinem Schaltschrank.
The main advantage of plug-in capability is, of course, when arresters have triggered and need to be replaced. They can simply be unplugged and replaced with new ones. It also has an advantage for insulation measurements, since the arrestor element can be removed from the system very easily. The base element can remain in the system. That is, if an arrestor needs to be replaced, simply pull the plug. The base element can remain wired, and only the plug needs replacing. This is the great advantage of plug-in capability, but it all comes together here. Development really did a great job, and the test lab gave us total support and also helped push the products to their limits. And it was a joy to see again and again how powerful the products actually are, and to keep testing and checking their performance. And then there is production, an absolutely essential link in this whole chain.
Die absolut ein wichtiger Bestandteil in dieser ganzen Kette.
At the end of every production line, the product is tested, either with a test pulse or a mini ampere point measurement, and then naturally, if it passes, it is forwarded for sale. With the SEC family, we have created a product range that is marked by extremely long service life. And with this product range, we can even promise our customers that we will provide free replacements for a limited time, even if the arrestor to be replaced was overloaded during operation. That is basically like a guarantee for a fuse.
So this was the video. We have heard a lot of aspects, and I will now further on go through the aspects again. So first, in overall, an overlook, what does safe energy control stands for? We have a safe handling of high energies with a new product, and we have an optimal energy control between the various levels of protection between type 1, type 2 and type 3 arresters. And so the surge protection with safe energy control offers outstanding durability, maximum performance, and it offers also an easy installation. So which products contain to the new family? We have lightning current arrestor type 1 plus type 2. We have a lightning current arrestor type 1 with integrated backup fuse. We have a lightning current arrestor type 1 with a new spark gap technology inside. We have a very small type 2 surge arrestor, and we have also a type 3 arrestor within the same product family, the plug trap. So how do we use these products to protect our building? The type 1 arresters are the strong arresters which can handle the whole current of a lightning. So the flash traps, the type 1 arresters from Phoenix Contact are called the flash traps. They are built in in the building entrance, and they handle the whole lightning current and are very strong and very robust. And then in the building behind the building entrance, we have also high wiring length to the devices, and in this cable length, also surges can come in. The surges can come in, and therefore we need type 2 arresters. The valve traps, they are installed in the sub-distribution of a building, and then in front of the devices are installed the type 3 arresters for the end devices. Highlights of the product family. So what is the main feature of each product? The flash trap SEC Plus, the type 1 arrestor is a pluggable type 1 arrestor for 230 and 400 volt systems with a line follow current free spark gap technology. And the flash trap SEC Plus 440 is also a type 1 arrestor for higher voltage levels. So it is for 400, 619 volt systems. Also with a line follow current free spark gap technology. Then the flash trap SEC Hybrid is a type 1 arrestor with integrated backup fuse, the only pluggable type 1 arrestor with integrated fuse, also line follow current free. And again, also we have the type 1 plus type 2 arrestor, the combination of type 1 and type 2 arrestor on 35 millimeters per pole. The type 2 arrestor, the smallest type 2 arrestor for DIN rails, and with a short circuit current rating of 50 kA and a maximum backup fuse of 315 amps. And the plug trap SEC, the device protection with integrated fuse also for AC systems and also for DC systems. So the highlights from the design. So we have here with the new product family, we have an identical appearance over the whole family. So if you see this design, you can be sure of the features of the whole family. We have a good handling, the new plug to plug out the plugs, and we have an eye-catching signaling. You can see on the first view if the status is red or it is green. We have an individual marking area on each plug. So if you have a look at the plug, on the top of the plug is the Phoenix Contact info region. You see the type classification of each arrestor, and you see also the description of the arrestor. And on the bottom of the plug you have a customer region where you can mark with individual labels. We have a screwdriver lever for easier plugging out the arrestors. All arrestors are turnable. They have a coding, and we can mount it in all orientation. So you can turn this base element upside down, and the plugs you can also turn so that you can still read the description on the plug. So this is all the Safe Energy Control family. And now to the main features of the new Safe Energy Control family. So the main features are that we are impact-free and durable with this family. We have within this family we have a solution without separate backup fuse for every application. We have compact and pluggable products, and we have high performance and high quality. So what do we mean with impact-free and durable? So therefore we have to understand what a line follow current is. If we install a spark gap, a type 1 arrestor with a spark gap, it is installed here. It is basically that we have two electrodes side by side, and we have no galvanic coupling within the spark gap, of course. And then here we have the grid, and we have backup fuse for the arrestor. And when the system is working normally, this surge protective device has no influence on the whole system. But then the spark gap, if we have an overvoltage, if we have a surge, the spark gap is ignited. So here we have a surge in the grid, and so the spark gap ignites, and we have the imposed current of the surge is discharged to ground, and now we have a very low impedance within the spark gap during this discharging moment. So we have a quasi short circuit within the spark gap, because now the spark gap has ignited, and the current flows, the surge current flows through the spark gap, and now the grid sees this quasi short circuit and also pushes the current through the surge protective device. And so it is this current that is caused by the grid and not by the surge is called the line follow current. This is the current that stresses the arrestor most, and stresses also the backup fuse in front, and it may lead to the blow of the backup fuse, for example. So with our new technology, we now have a line follow current free spark gap technology. So this is now the smooth way to discharge the lightning currents, because we only have a minimum of energy that is led through the surge protective device and led through the electrical installation. And so this leads us to the higher durability, because we have lower wear for the spark gap and lower wear also for the fuses. We have less stress for the surge protective device, and we have minimal maintenance cost for the electrical installation. So now a short video about the theory of the line follow current. How does it appear and what does it mean with the new technology?
Safe energy control technology from Phoenix Contact. With common spark gaps, a line follow current flows after triggering. This leads to increased wear and frequently to the backup fuse being tripped. The downstream system is then switched off unexpectedly. Spark gaps with safe energy control technology from Phoenix Contact prevent line follow currents, reduce wear, and increase system availability. The influence-free and durable surge protective devices from the SEC product range protect your system even more effectively and reliably in the long run. Safe energy control technology from Phoenix Contact.
So this is the theory behind the line follow current free spark gap technology. We have better durability for the spark gap and also greater availability for the system. And we also have one practical video which shows a typical installation in our laboratory, and there we test the old technology, the old spark gap technology, and the new spark gap technology, and look how they behave.
The behavior of different spark gaps is shown with two tests using surge current coupling. The first test shows the spark gap of the formerly used technology and the adverse effect on the system and the connected device. The second test shows the spark gap of the unique Phoenix Contact Safe Energy Control technology, which prevents any adverse effects.
So that was the topic about the new line follow current free spark gap technology. The second main feature of the new product family, Safe Energy Control, is the solution without separate backup fuse for every application. So in the standards, the standards describes two ways for an overcurrent protection of a surge protective device. So here is one way. We have here a main fuse, the F1 main fuse, and here is the electrical installation behind that we wanted to protect. And here in branch wiring we have the surge protective device, and in the same branch, in the same wire level, we have the F2 fuse, a separate backup fuse. This is one possibility, and another possibility is that we use the main overcurrent protection, the main fuse F1, also as overcurrent protection for the surge protective device, and no separate backup fuse for the branch wiring. And for this application, for this installation method, we have quite high. With the new family, we have a lot of applications that can be done within this application form. And the advantage is that we have lower cable lengths. We do not need to wire the F2 fuse, and we do not need the space of a separate F2 fuse. And so it is very interesting to use this installation, the second installation method, without a separate backup fuse in front. And this is possible with the new products. So for example, for a type 1 arrestor, if we have the power supply and the main fuse is 315 amps or lower, we can install a typical type 1 arrestor of the new family without a separate fuse, without a separate F2 backup fuse. And for installations where the main fuse is higher than 315 amps, we can use the flash trap SEC hybrid, also without or still without separate backup fuse in the branch wiring, because the flash trap SEC hybrid is a type 1 arrestor with an integrated backup fuse. So again, here you do not need to wire the additional fuse. What is also still possible is to use the standard type 1 arrestor without integrated backup fuse and install a separate fuse in front. It is possible, but here it is more space saving and you do not need to wire a separate fuse. So what does it mean for the different product families? If we look at the current rating of the main fuse, the F1 fuse, for our type 1 arrestors, the standard type 1 arrestors can be installed without additional backup fuse up to 315 amps. If the F1 fuse is 315 amps, you can install the type 1 arrestor without additional fuse. And over 315 amps, we can still install the flash trap SEC hybrid without additional backup fuse. Also for the type 2 arrestors, we can install them up to 315 amps. And if we have more than 315 amps, we can use a combination of type 2 arrestor and MCB. And for the type 3 arrestor, it has an integrated fuse and it can be installed without additional backup fuse in front. So the third kind of family is compact and pluggable. So with the new family, and within the new family, all arrestors in this family are pluggable, and this is very good for installation tests, because if we do an installation test, we have to unwire the surge protective devices because they have an influence on the installation tests. And if we use pluggable surge protective devices, we do not need to rewire during an installation test. And also, if the plugs are overloaded, for example, and have to be replaced, we can just simply pull out the plug and put in a new one. And if you do not use a surge protective device which is pluggable, you always have to rewire your system. And second point, all arrestors are space saving and easy to install. So what does this mean? Here, for example, is one example how we can save space with using a safe energy control technology. So one example is using the flash trap SEC hybrid for a type 1 application. If you have a typical type 1 application, we need the separate backup fuse and the type 1 arrestor. And with the flash trap SEC hybrid that has an integrated fuse, we can save a lot of space if we compare it to the standard installation, because here the fuse is integrated and we do not need the separate fuse. Other possibilities for space-saving solutions are in the portfolio are the type 1 and type 2 protection in one product. So we have a combination, one product with 143 millimeters that is type 1 and type 2 plugs, has type 1 and type 2 plugs inside, and we save 27% space compared to the standard sizes if we use two separate products. And for the type 2 portfolio, we have the smallest type 2 portfolio, type 2 arrestor for DIN rails, and we save 30% compared to the standard sized type 2 arrestors. So these are just examples for the compact installation. And last but not least, the high performance and the high quality. So because of our new technology, our new line follow current free technology, we promise the following thing. It is getting the green light. We bet that you won't see red for 5 years. With low wear protective devices, you won't have to worry about replacing wear parts for at least 5 years. Because of the SEC technology, the high-quality components are particularly durable. However, should the status indicator signal the need for replacement within the first 5 years following your purchase, you will receive free replacement plugs. You only have to send back the affected plug to us. So this is what we promise with the new Safe Energy Control family. Greater availability, less stress for the system, and free replacement if they are overloaded within the first 5 years. So all these are the benefits for your success. So now to the last point, the application examples. So principally, the Safe Energy Control technology is a surge protective devices for the power supply, and power supply is used in all industries. So we have a wide range of applications for the surge protective devices. And just for some examples, for example, in big buildings or in big infrastructure projects, we always need very durable and very high-performing arresters. So our Type 1 arresters, the flash trap, as you see, are the cornerstone for each reliable lightning protection. And we have really high-performing Type 1 arresters with the new spark gap technology inside. And another example for energies or for wind industries, there we often have the need for higher voltage levels, and in the new portfolio is also a Type 1 arrestor for 400, 690 volt systems, or for 400 volt IT systems, which is very, very compact, has a standard Type 1 design, standard Type 1 size. It is pluggable, and it is certified by independent bodies. So the third example for building industry, for example, or also for telecom industry, is the Type 1 plus Type 2 in one product. So it is really a universal protection, which can be installed in most applications. It is the lightning protection for devices. It has a lightning protection and also surge protection from switching operations, and it is space saving, and it is also easy to install. And one last example for machine building industry, for cabinet builders, their space is always a matter for cabinet builders, and there we have the Type 2 arrestor which needs 30% less space than other Type 2 arresters, and it has a very high maximum backup fuse rating, which leads us to be able to not to use a separate backup fuse in front. And also the Type 3 arrestor is interesting for this industry, which has a safe, which we can save the space of a separate backup fuse in front, because the Type 3 arrestor has an integrated fuse, and this is a good way to protect your power supplies. So quite a wide range of applications for the new family. And now principally I'm done with my presentation about the new surge protective devices from Phoenix Contact.